Welcome to solverfy.
So we have a spherical shell and a charge Q at its center. A spherical metal shell, by the way. We want to find out the field in different regions. Now, inside the spherical shell, within the spherical shell, what will the field be? Now, you can simply draw a Gaussian surface, a sphere of radius r, and you'll see that the only charge enclosed inside is Q. So, the field must be and because the system is spherically symmetric, you expect the field to be spherical, radial. And now that you have this, you can see that the only charge that can produce this field E is this center charge. Therefore, E must be of the form 1 by 4 by epsilon naught Q by r squared. Now, for part B, what happens inside the spherical shell in this region? To think about that, we know that inside metals, the inside conducting materials, field is 0. So that's simply 0. So see, what about outside the electric field? For that, we can start by drawing a Gaussian surface within the shell, inside the shell. Now, because the field here is 0, the flux must be 0. But this flux, we know that by Gauss's law, flux is equal to charge enclosed divided by epsilon naught. Hence, the charge enclosed must also be 0. But we have a Q charge here, don't we, at the center? So how can the charge enclosed be 0? For that, there is a minus Q charge induced on the inner surface of the sphere. So we have the sphere. So there is Q at the center, which means there is a minus Q on the inner surface. But the sphere was initially uncharged, which means there must be an induced plus Q charge outside the sphere. And because this is spherical, the charge will distribute itself uniformly over its surface. And because it's spherical, at any point outside the shell, it acts as if the whole charge has been concentrated at the center. Hence, at any point outside, the field is again 1 by 4 by epsilon naught Q by r squared. So for part D, we want to think about if this shell changed the effect of this charge Q at all. Seemingly, inside this region, inside the sphere, within the shell, and outside the shell, there is no difference except for within the shell, that is in the metal conductor itself, the field has changed. That is it. So the field remains constant inside and outside, but it changes it within itself. And what about the induced charges? As we've already seen, it has induced a charge of minus Q on the inner surface and a charge of plus Q on the outer surface, which means this plus Q charge has induced these two charges on the spherical shell. That is it.